All right, let's look at number 2 in 16.2. And we want to find 0 to 3 f of x, y, dx for the first thing. So 0 to 3 y over x plus 2 dx. That means y is constant. So this is like integrating y, 0 to 3 x plus 2 to the negative 1 dx. That's going to be y ln x plus 2. I don't need absolute value here because x is positive. It's going from 0 to 3. So this is going to be y ln of 5 minus ln 2, which is y ln 5 halves. Okay, that's it. And then I want to integrate 0 to 4 f x y dy. This time x is held constant. Let me separate it out. So this time this is a constant. So I'm integrating y. And then I'm substituting in 0 to 4 for y. These are y values because we're doing it dy. So I have 16/2 is 8. So I have 1 over x plus 2 is 8. Minus 0, 0. So I just have 8 over x plus 2. Okay, let's look at number 8. 8 is a double integral 0 to 1, 1 to 2, x e to the x over y dy dx. Okay, so the first thing we're doing when we do it with dy is x is constant. So x e to the x is constant. I'm just integrating 1 over y, which is ln y. And I don't need absolute value again because I'm going from 1 to 2, so I know y is positive. These are y values because it's dy. So I have x e to the x ln of 2 minus ln of 1. ln of 1 is 0, so this is just x e to the x ln 2. All right, now I take that and integrate from 0 to 1 dx. Well, ln 2 is constant, so it can go out here. Okay, here you have to integrate by parts. I'm going to use the shortcut where you take the derivative on this side of the x, and then you integrate e to the x, and this is integration by parts, and then you multiply and alternate the signs. So this is going to be ln of 2 x e to the x minus e to the x from 0 to 1. So this is ln of 2 e to the 1 minus e to the 1 minus 0 minus 1. So that's just 1 times ln 2, which is ln 2. So that's my final answer. Let's look at 14. I have this region rectangle, and I'm integrating cosine x plus 2y dA. And I have x between 0 and pi, and y is between pi over 2 and 0. So first I'm going to integrate with respect to x. So for x, I'm going to go from 0 to pi cosine x plus 2y dx. The integral of cosine is sine. Y is a constant here. Substitute these in for x. I have sine of pi plus 2y minus sine 2y. Now I'm integrating that with respect to y, and y goes from 0 to pi over 2. The integral of sine is minus cosine, and then I have to adjust it by this 2 right here. And minus cosine again, so that's going to turn it to plus. And again, I have to adjust it by this 2, this 2. And that's from 0 to pi over 2. Those are y values. So, oh, this is pi. Plug in pi over 2. So that's going to be cosine of 2 pi is 1. So that's going to be minus a half. Cosine of pi is minus 1. So that's minus a half. And then plug in 0. Cosine of pi is negative 1. So this is going to be a half. Cosine of 0 is 1. So that's going to be a half. So this is all going to be minus 2. So in that case, this doesn't represent a volume because it's negative. Okay, let's try 26. And this is bounded by the planes. So we're just going to, it doesn't matter how we do this. So let's try 0 to pi, 1 plus e to the x, sine y. Y is between 0 and pi, so this is dy. And then the x is going to go from negative 1 to 1, because it's right here, x is bounded by plus or minus 1, dx. Okay, now this is continuous function, so it doesn't matter the order of integration. If I do y first, that means x is a constant, so e to the x is constant. So that's going to be integral 1 is y. Integral sine is minus cosine. E to the x is constant, and I go from 0 to pi. And those are y values, so I have pi minus e to the x. Cosine of pi is negative 1 minus 0 minus cosine of y is 1, so that's e to the x. So this is going to be pi plus 2e to the x. Then I'm going to go from negative 1 to 1 with respect to x. And that's going to be my final answer. Okay, let's look at some more maple. And for that, I'm going to do number 32 using maple. So let's open that again. Okay, so 32 asks us to graph the solid that lies between these two surfaces and then use maple to approximate the volume of this solid to 4 places. Okay, so first I need 2 packages. I need with plots package and student package. So I'm going to go with plots because I'm going to graph it. And I also need with student. I need the student package. Okay, so let's plot it first. Plot 3D. E to the negative x squared times cosine x squared plus y squared. And I'm going to plot the other one is 2 minus x squared minus y squared. So I'm going to plot those two functions, and I'm going to go from -1 to 1 and -1 to 1. Okay, so it's two, they're like sitting on top of each other, and you can twist them around and see. You want the spaces between those two humps. Okay, so let's try double integral. And instead of writing all this again, I'm just going to copy it. So I have actually the e is on the bottom, is the bottom function. You can test the point to see that. So this is going to be negative that plus this function. So you're going to take the second function, because that's on top, and you're going to subtract from it the e function, because that function's on the bottom. And then we're going to integrate from -1 to 1. That's why how I picked the domain above, the book said go from -1 to 1 in both x and y. So we'll get this double integral. Again, you can reverse that. The 2 minus x squared minus y squared is the top function. So you take the top function minus the bottom function when you do this integration. Okay, then I'm going to just integrate with respect to x first. See, this just gives us the symbols. Okay, so I'm going to integrate this with respect to x first. Takes a while to do that. Okay, you get this big mess with complex numbers. Then I'm going to integrate the above expression with respect to y. And you don't have to know what all those functions are, the ERF function, but I is a complex number. We want to evaluate this, what number this is equal to, so we do val percent, and we want it 5, let's do it to 5 places. This book says 4 decimals, so we'll round up. Oh, forgot, it's eval f. And that's like 0 times I, so the imaginary part really isn't a big deal there. That 5 says 5 significant digits, so I just want the real part of this, which is that first number, because it disappears. That's going to be 0, pretty much 0 times I. So that's what the double integral is going to give us using Maple. So that's number 32. You can look at some of the sample homework problems to see more examples.